one more. Actually, we're in the unit number 3 related to hydraulic circuit designs and working. In the previous class, we have gone the basic difference between hydraulic operated circuit and pneumatic operated circuit. In the case of hydraulic, we'll be utilizing depressurized fluids, and indeed to impart the pressure, motor plays a major important role, which is supplied externally that used to create the pressure in the fluid, which is incompressible, that will be driving to a particular destination from the oil reservoir by using different traveling media. That we have been discussed the basic hydraulic circuit in the previous session, that the motor here sucks the fluid from the soil reservoir, and by the help of these pressure relief valves, the set pressure of fluid will be driving towards the actuation system with the help of this directional control valve. And there is a non-return valve which is placed in front of this motor indeed to obstruct the backflow of the fluid. Indeed to operate the system in a safe operating pressure, the pressure relief valve plays a major important role, that the gauge will identify the nominal amount of pressure which is to be supplied to the system, and it operates in a safe pressure because of this pressure relief valve, which will traps the additional pressure that is being attained with respect to the fluid, and that fluid will be drained by filtering back to the oil reservoir in such a way. Due to the operation of this directional control valve towards the forward stroke, it will be moving on with respect to the throttling condition, and, other the sequence basis of condition towards the forward motion in controlled manner. Simultaneously, the, the third position has been brought into the highlight. It will be moving on in reverse position, that monitored with respect to the throttling valve at a controlled pressure. So here, sequence valve and throttling valve both plays a major important role indeed to control the actuation positions and the output range. And for the commencement of this forward stroke and return stroke, this directional control valve plays a major important role. Either it is having four different modes of operating, as we have discussed in the previous class. That first one, it is in mechanical mode, second one, it is in the electrical mode or solenoid mode, third one hydraulic, and fourth one is pneumatic considerations. As shown in the diagram, it is in mechanical mode of operating the actuator with the help of this lever system. And we are aware of that the nomenclature of this directional control valve is having four different ports and three different positions. Initially, it will be connected ideally to no connections. There is null position. At that particular position, fluid which is pumping by the motor will be coming back again by draining to the oil reservoir, and there are no any connections that are made here, and this is a null position. If the plunger 1 or lever 1 is actuated, position 1 will be coming into the high level position and will be connected towards the forward stroke of the actuator. Simultaneously, the third position came into the force upon actuation, the return stroke of this actuator coming to the position. So this is the operating condition that we have been seen in the previous session, and here it is clearly displaying the simple hydraulic circuit that based upon the control valve lever position is the lever position actually connected here also. So this lever having three different steps. First one is a null step and retraction step and the extension step. So three different steps. Commonly connected in the middle, if you have been connected this, commonly it will be connected. So when it has been connected, this is the directional control valve which will, for extension, it will be connecting from this port to this port. So port 1, 2, 3, 4, and 4 to 2 it will be connecting, forward stroke will be energizing, and the fluid already entered, or the forward stroke which is leaving will be connected from 3 port to 1 port. It will be draining to the reservoir. Simultaneously, when in retraction stroke the lever has been connected, the cross connections will be getting made, or straight connections will be getting made. That from 1 to 2 it will be connected as shown in the diagram. From 1 to 3 it will be back as a forward stroke, and return will be connected towards the exhalation channel, and this will be flown back to the return conditions from 1 to 3, and simultaneously from back it will be entering, and from here, and automatically one port will be connected here. This will back towards the drive back towards the reservoir oil reservoir. So this is the common condition that is being arrived in the case of this oil operated, nothing but hydraulic operated circuit system. So moving on with respect to some of the components which are interacted towards it, and how this DCV plays a major important role due to control the actuation position. We'll be having a detailed look. Here the animation shows the sequence of basic hydraulic circuit which is connected with respect to an actuation and spring return. Here it clearly specifies here spring return of 4 by 2 way valve. So 4 by 2 way, here clearly specifying that how many ports that it is having and positions it is having. So this is one position and this is the second position. So two different positions it is having, advance and return of the drive component, which is having a double acting cylinder. The double acting cylinder which is having both forward strokes simultaneously the return stroke, and the opening and closing of the pressure relief valve. And the DCV itself actuating that straightforwardly it is activating towards the as an pressure relief valve also, and it is trapping towards the oil reservoir back again, and even from this side also. So it is directly connected towards the oil reservoir. So here we'll be having a clear picture look. The tension which is causing within the spring is attached in the DCV, and this is a push button type of system, and previously we have been seen the lever type of operating system. But both the actuation systems or directional control valves will be coming under the mechanical mode of actuating only. When the switch has been actuated, these are the connections will be coming into the constraints that happens the forward stroke. Only when the push button is operated, then the forward stroke will be containing, because the oil that is being entering here is an input, and red color will be highlighting towards this direction, and blue color will be highlighting towards this direction. And hence a straight connections when you have been pushed this button, these two connections will be coming into these positions. It will be entering in a forward direction, and the return fluid will be drained back to the oil reservoir. That is the first condition. And at the but initial stage, already entered fluid will be drained to the this oil reservoir back again. And next one it is if the automatically if you have been released the external pressure on the push button, the tension causing in the spring will get into its original position by extending. At that particular time, the original connections which are made here will be coming into the force. The fluid which is being having the pressure will be entering into the right side direction, and the piston passes towards the left side movement, and already entered fluid in the left side direction will be coming back to the oil reservoir. So this is the interaction that is being done in the case of this hydraulic system for actuating double acting cylinder. So nominally this is an hydraulic power unit that is maintained at the overhead of this oil reservoir need to commence the forward activity. So here, before entering towards the system, so before entering the directional control valve, this is called input system, and after crossing the DCV, that is called directional control valve, this is called output system. So this is an components or circuit diagram related towards the input system, because after crossing this motor by imparting a particular pressure, it will be entering into the directional control valve, and which the directional control valve directly passes the fluid to the actuator for its movement, causing the movement within it, either in forward direction or else in the return direction. Here, the example or the diagram that shows the detailed circuit symbolic representation of a hydraulic power unit, and hence this is called overall this power hydraulic power unit. It is a comprises of an dash dashpot or dash line here, and that is dash line which is placed around the symbols representing each and every individual units. So this is comprises of the components that we will be seeing presently. And this is the oil reservoir or tank, and this is the oil level measurement within the tank indicates. And next one it is an filtering. By filtering, it will be entering into the motor pump, and when the motor has been switched on, it pumps the fluid towards the forward direction. So before entering into the DCB, the level gauge measures the pressure which is being entering, and the set pressure will be enters to the DCB from the input unit, and if the additional power has been produced simultaneously, it will be coming back into the sequence valve or pressure relief valve, and this relief valve will be actuating into it. The fluid will be flowing by flowing here. The fluid enters here. High pressure, if there is any existence, it will let the input of this consideration spring will be getting contracted. The level of contact will be coming into the actuation. The additional pressurized fluid will be flow or back to the oil reservoir. There is a condition. So here it clearly specifies the pressure relief valve. That is nothing but entering the fluid here and pressing this. So nothing but when the fluid enters here into the A section, this causes the tension within the spring or compression structure within the spring. Nothing but the opposing pressure will not be existing because of the additional force that is being entering in the form of a pressurized fluid that causes the compression within the spring. Compression within the spring due to the movement of this plunger towards the backward direction. So at that particular time, the inlet will be getting opened up to when the set pressure will be kept here by throttling. So if the 3 bar of pressure need to be entered into the input of that VCB or to the circuit system and towards the output range, indeed to activate the actuator, the 3 bar of pressure will be setting here that opposes by the spring, and hence that tension will be created in it. So when that 5 bar other than that crossing the 3 bar of pressure, then if the 4 bar of pressure is entering here, that 1 bar until that 1 bar of pressure has been released from the entering stage towards the directly, it will be drained back to the oil reservoir until that 1 bar of pressure has been released. The tension or compression will be getting created within the spring. So if 3 bar of pressure is maintaining simultaneously, tension also maintaining the same string, we are all aware of that Newton's third law, that entering pressure externally is equal to the maintaining pressure within the spring, that equilibrate this and will not allow the fluid to flow into the pressure relief valve. So hence the equal pressure that is set within the pressure relief valve and the pressure that is operating in the circuit, which is important to imparted to the fluid, is similar, then the plunger will be getting in closed condition, right? So hence this is the case of releasing the excess pressure that is being entering into the system, which creates the highly inconvenience for the operating sector. So that is one of the major parameter or advantage by the utilization of this pressure relief valve. And condition number two. So here, when the force that is exerted, the inlet pressure A exceeds the opposing spring pressure. So nothing but the limit in the spring has been set with respect to the pressure of for 3 bar that has been considered. So if 4 bar of fluid is entering or pumped from the motor, then the additional pressure will be entering towards this and plunger will be getting contracted. That is nothing but compression state into the compression state, and that fluid which is having additional pressure will be left to the oil reservoir. So that is the condition. So we will be looking at a small examples of when it is connected towards the system, we need to commence in a proper actuation towards the forward stroke or else the return stroke, forward stroke and return stroke. The examples which is operating under the circuit in a safe pressure or limiting the pressure or operating in the same pressure of the circuit, will be having a detailed look in the overall operating system by the hydraulic components. So here shows a pressure relief valve with a basic hydraulic circuit which is used to control the double acting cylinder. So double acting cylinder here we are all aware of that it is having both forward stroke simultaneously the return stroke also as well. So if you have been verifying here within the oil reservoir, we all aware of this pressure head or inlet pressure head. This dotted line specifies that the arrangement of inlet pressure head will maintain the particular pressure by to the fluid and will let the particular pressure containing the fluid to the inlet conditions of the directional control valve. Here we will be having a detailed look. Here this is a sequence of pressure relief valve which the motor specifies or imparts the pressure by the help of this pump for about 4 bar of pressure. So if the overall equipment is set with respect to an 3 bar of pressure, and this 4 bar of pressure will be acting from the oil reservoir. The motor will pump the fluid with the 4 bar of pressure, and additionally entering pressure will be measured here by the pressure gauge, and 1 bar of pressure will be released to the oil tank. So 3 bar of pressure will be entering to the system inlet condition. So before entering here, there is a check valve over here, and before entering towards the directional control valve, it is verified by this pressure relief valve, because the system suddenly has to be decreased to by the 1 bar of pressure to be operated due to the environmental conditions that are being taking place in the external situations have to limit the pressure. So at the inlet condition, already 1 bar of pressure has been limited. So it is impossible to limit the pressure after crossing this DCV. Sorry, not the DCV, this is check valve. So because check valve acts a major important role, that it doesn't allow the fluid to flow backside. So if the fluid has been flown in the backside or nothing but the motor has been switched off simultaneously, the fluid will not be even 1 bar of fluid also will not be entering into the circuit design. So continuous supply should be existed, but limiting of pressure after crossing this check valve is impossible by this particular unit to decrease the pressure which is caused in the fluid already. So hence after crossing this non-return valve, that is nothing but the check valve, will be placing another one more sequence valve or pressure relief valve. Here there is OB2, pressure relief valve. And hence here pressure relief valve is to limit the system pressure. Nothing but the fluid which is entered by 3 bar of pressure is coming here, and this is the gauge that measures the 3 bar of pressure which enters, which is ready to enter into the DCV or into the system, that the system specifies that only 2 bar of pressure is sufficient for operating this actuator towards the forward and return strokes. So hence at that particular time we have to reduce 1 bar of pressure. Hence this pressure relief valve plays a major role, that will be setting a pressure within this gauge by 2 bar with the 2 bar, and next 3 bar of pressure will be entering here, and already we have been seen in the previous diagram that this is the system. 3 bar of pressure will be entering into the pressure relief valve, and hence here 2 bar only has been set up, and the pressure will enters into the fluid. The fluid will be enters into this valve. This causes the compression within the spring. This dashpot or knob will be getting in open condition because of the Newton's law. The highest pressure than the opposing pressure has been entering until it maintains the equal pressure. So set pressure here it is 2 bar, and 2 bar until the 2 bar of pressure entering externally will be compensated with respect to this spring, and that when it has been came into the equilibrium by releasing the 1 bar of pressure into the oil reservoir back again. That is nothing but this will be getting an open condition. 3 bar of pressure which is already crossing this non-return valve, check valve will be entering here, and some of the fluid which has a high pressure, there is 2 bar of set pressure, 3 bar of pressure enters here, and 1 bar of pressure will be drained towards the oil reservoir back again. And before that, we'll be utilizing this filtering process, because it is entering from pump to the from crossing the check valve and entering into the sequence valves and relief valves, different relief valves, and it will be mixing with respect to the interlines of the some of the uh, dust particles that are being existing, that will be getting filtered out with the help of this filter and will be drained back to the oil reservoir, and the same fluid will be again put to the system. And this is the continuous system that is being taking place for dropping the pressure to have the safety conditions need to operate this actuator with the directional proportionate of this directional control valve. If the plunger has been in first converting condition, if it moves towards the forward direction, that causes the compression in the spring, causes this motion, that is, the fluid will be entering the first A channel and causes towards the forward movement and releases towards the left side direction. And this is the condition that is having here and releases to the oil reservoir. Simultaneously, towards the left condition, the causing spring compression will be releasing here and same position will be getting highlighted from port number 1 to port number 3. The oil will be moving and return stroke will be considering, and port number 2 to 4 it will be releasing to the oil reservoir. So this is the condition, and here the major role is nothing but the pressure relief valve plays a major important role. You need to limit the pressure or drop out the additional pressure that is entering into the system and need to operate the entire system in safe conditions, or else sudden movement will be taking place which causes no obstructions here, that causes the fitting conditions of the environment at the outside. So that causes the inconvenience in the operational sector, causes many of the hazardous situations also even. So you need to limit those all situations. Hence, the pressure is being dropped out, and so slow action will be considered by the actuator towards its forward stroke, simultaneously its return stroke. So this is the PRV, pressure relief valve considerations. And next, we'll be having a detailed look towards the utilization of this pressure relief valve with respect to utilization by utilizing an brake valve. So brake valve. So here we'll be having a detailed look here towards this pressure relief valve used as a brake valve. The circuit which is displaying here incorporates not only a brake valve on the piston rod set. So piston rod set, this is the piston rod set. The actuator, cylinder piston arrangement and piston rod set. So it is fixed. Pressure relief valve is fixed here. So, what is the operational conditions we'll be having? A detailed look, right? Non-return valve, but also a non-return valve on the inlet side via which oil can be taken in from a reservoir during the vacuum phase following the closure of the directional control valve. So nothing but here. So before entering into this directional control valve also, it is acting as a non-return valve condition. So non-return valve condition in the sense it will doesn't have any backflow conditions of the fluid. So here the following animation shows in which occur in two working lines. So considering that inlet condition also sequence valve or pressure relief valve is being attained. Indeed, to allow only the set pressure into the inlet conditions and even output condition also. So, as we have discussed presently, the movement of this piston is very much speed. Nothing but this m is nothing but the mass. So this mass should be or weight should be carried slowly. So if it is causing suddenly, if the grip has been released, it causes damage to the environment or any number of population may get damaged and even leads to the life risk also. So indeed to safeguard the situations, slow movement is required because highest pressure is being entered into the inlet that causes the movement towards the forward stroke in a quick manner with a high pressure, and at that conditions towards the output line will be maintaining an pressure relief valve that allows only simple pressure that causes slow movement over here, because if it is entering with respect to 2 bar of pressure, when it is released towards the reservoir reservoir that is nothing but towards the environmental criteria. So it causes within the universe, environmental criteria specifies here universal standard pressures. So entering it an 2 bar of pressure, and universal pressure it is 1 bar of pressure. Because of it is less, it is directly releasing continuously to the environmental pressure and invert towards the output to the reservoir. Hence, it causes very much speed in extension positions, even in the contraction positions also when it is connected to the return stroke also towards the reservoir. So, hence, to limit that particular speed, the pressure relief valve entering towards this here. We need to compensate this 2 bar of pressure which is entering into the fluid to the towards right side also by decreasing only that 1.9 bar of pressure. So that zero point 0.1 bar of pressure will compensate the slow movement of creating piston movement towards the right side direction, that is nothing but towards the forward stroke, causing the movement in the mass which is contained. So hence we will be having a detailed look here. Initially this is oil reservoir on an hydraulic circuit system, and which allows or pumps the fluid, and additional pressure will be trapped back by this pressure relief valve to the oil reservoir back again. And when the plunger is activated in the forward stroke, this position 1 will be getting into the higher position, and this is the directional control valve which directs the forward stroke of the actuator or return stroke of the actuator. And these are the three different positions having. First, in middle one it is a null position, and the lever is activated in the forward direction. This first position will be coming into the force, and when lever is uh, set into a return direction, this extension causes in the spring, and the second position will be coming into the force. Our main motto is to limit the pressure or movement of this piston rod to a safe operating conditions. When this position 1, let's have the look of this forward stroke and return stroke here by operating this DC. When this first plunger has been operated with respect to the forward condition, first position will be continuing to the force. This is the port number 1, 2, 3, and 4. 1 and 2 will be getting connected. This oil will be moved or will be moving to the forward directions, and which causes the pressure relief valve maintaining with a nominal amount of difference in the pressure. For example, entering pressure it is 2 bar of pressure, and releasing will be of 1.9 bar of pressure, that is 0.1 pressure classes, 1 bar of pressure classes the movement towards the forward direction, because the extension towards the inlet condition is very much more, or that is 0.1 bar of pressure is more in the case of inlet, creates the forward movement of the piston movement, and simultaneously it doesn't allows the fluid towards the reservoir movement even it is connected in the inlet condition, because this is a non-return valve or check valve which doesn't allow to pass the fluid to the oil reservoir. Hence the safe generated 2 bar of fluid will be entering only to the inlet condition. So this is the first movement, and upon movement, these movements will be getting limited by increasing this pressure also. So if this set pressure has been increased, we can maintain with respect to the pressure valve increasing or decreasing. So this throttling conditions and the knob can be adjusted. So that is the condition that will be taking place here. So that set pressure will be monitored here. To this sequence or pressure relief valve will drive back the fluid slowly to the oil reservoir. So this connected here to the oil reservoir. We'll be observing the return stroke. If the lever has been operated in second condition, that is second condition, and in the second condition, this port 1 will be actuating to the port 3, and hence fluid is being entering into this uh, return stroke for the return stroke. So here also we will be maintaining the same conditions. Pressure relief valve, which is at an maintained at a set pressure, will be allowing the fluid to flow through the this port number 2 in the cylinder, and this creates the backward movement, and at the time of this backward movement the fluid already entered here will have to move towards this direction. At this particular junction it acts as a bilateral movement towards this direction, towards this direction. Nominally, the pressurized fluid will be tends to move in n number of directions that it is having. But here we are placing this check valve or non-return valve, which doesn't allow the fluid to flow back, which is connected to the oil reservoir. And compulsorily it doesn't allow here, and it's having only one passage of movement, which is connected to the second position, will allow the drive the fluid to the oil reservoir. So here this is the basic condition that pressure relief valve plays a major role in that it acts as a safe pressure for movement of this piston towards the forward stroke, that is limiting its motion by creating or imparting the pressure constraints, and even moving towards the backward direction by positioning this non-return valve or check valve here, and operating with respect and safety pressure by this pressure relief valve entering in the return direction. So this is called brake valve, nothing but stopping the additional pressure is nothing but the brake type of valve. That is nothing but stopping the additional pressure from the fluid that is being entering into the circuit system, which creates an speed reactions that causes the inconvenience in the plant situations. So it may leads towards the hazardous situations, that if a high amount of weights are being lifted, if suddenly on the random movement, sudden changes has been occurred, for the quick reactions if the grip has been lost, suddenly that weight is that a large weight for about 20 tons or 30 tons is being lifted by a wagon is suddenly released, then it causes inconvenience for the public. So for that particular situation, the pressure relief valves will be utilizing in there to decrease the pressure in the particular situation, to move in slow actions by incorporation of this pressure relief valves. And hence also this is also called in for stopping this pressure created, and to maintain in a safe mode of operations or set limit of pressure, this is also named as brake valve, hence brake valve, correct. And next one is an industrial hydraulic circuits. There are typical hydraulic circuits for control on industrial machinery, which are described from here. That is, the graphical hydraulic circuit designs, or the the pictorial representations or diagrammatical representations, which incorporates the component symbols used to explain the operation of the circuits. And coming to the point of these industrial hydraulic circuits. So industrial hydraulic circuits creates the loading actual as well as the unloading conditions in the machinery by the material, or else loading towards the transportation wagon for transportation to, so from source place to the different destination places. So loading conditions will be occurring, and for the plant operation, if the raw material has been arrived to the company, the unloading also to be maintained simultaneously. So unloading system for energy saving, and even the operating conditions for both the systems simultaneously with a single motor, that plays a major crucial role. Nothing but the same actions need to be performed by a single element of conditions which can create the pressure of same simple monitoring conditions, which is maintaining the simple monitoring conditions. Just really have a detailed glance over it that an unloading system is used to divert the pump flow to the tank during a part of the operational cycle to reduce the power demand. Nothing but indeed to operate the system in unsafe conditions. The presently till now we have been utilizing the pressure relief valve. Simultaneously, here we will be utilizing these unloading conditions. Nothing but reducing of the power as per the demand required. So generation of highest pressure that leads to damage of the system pressure, and hence this unloading of this pressure plays a major role. So this is done to avoid wasting power ideal periods. So because by creating the previous session that we have discussed that breakpoint. So initially motor is creating pressure, and with the help of this pressure relief valve we are releasing the pressure. So creating and releasing. So this is an heavy cost effective, and because the work is being done here, time is consuming, inputs raw material is being taken, power is being considering, so it relates an economical constraint. So instead of avoiding that wastage of power and even time period for creating the pressure or for the pressure in the fluid that will decrease to some extent for adjusting the similar generated pressure. Nothing but 4 bar of pressure is being utilized and simultaneously distributing the 2 bar of pressure to one system and 2 bar of pressure to other system simultaneously with a single device. So this pressure relief also doesn't act much more in this particular situation because loss of power is being considered here, which creates the much economical loss also. We are creating the pressure for creating it is economical, it is utilized, time is being utilized, different machineries are being in working condition, and we are dropping the pressure again by leaving it as an ideal. So here that plays a major important role that already generated pressure without unloading, how we can adjust the same generated power to the operation of another circuit also. Here will be having detailed look that, for example, it is often desirable to combine the delivery of two pumps to achieve the higher flow rates for high speed with the cylinder is advancing at low pressure. However, there may be considerable portions of the cycle such as the cycle uses heavy loads and heavy speeds is no longer required and cannot sustain the bacteria by the prime mover. It results, the unloading results in an by the pump is to be unloaded, resulting in a reduction of speed and consequently were also the components of system A and B hydraulic pumps, C and E, pilot operating spring, loading relief valves, and the check valves. So here it clearly specifies the components also here. Nothing but it is similar pump which is creating the pressure is being utilized for operating of dual conditions, two different conditions, and these two different conditions are nothing but when the system needs heavy pressure for its operation, in that situation we have to utilize nothing but till now we have been seen that only 4 bar of pressure or 3 bar of pressure is sufficient for running. So if furthermore additionally pressure is required, this condition is this condition can satisfy. So or else simple pressure, second condition it is simple pressure is sufficient for operation, but this motor generates a heavy pressure at that particular time. The pressure which is created will be split into two different groups and allowed into two different distribution channels or two different machineries of working, or indeed to work or commencement the work by the two different actuators, right? That will be looking in the next class. Thank you.